Hey everyone, Kyle Walker here. If you love cars, fixing things, or just want to understand your vehicle better, you're in the right place. I share hands-on tips, smart driving advice, and straight-up car talk without the fluff. Make sure to hit that like button, subscribe to the channel, and stick around till the end. You don't want to miss what's coming up. Let's get into it.
The vast majority of motorists and ordinary motorists have definitely encountered the concept of engine lasing. Not everyone fully understands what it means and how such a procedure is carried out. Boring, as well as boring, affects the engine cylinder block. Such operations are performed as part of overhaul, i.e., overhaul of the power unit. If we talk about boring, it is a method of eliminating existing defects on the cylinder walls. It is done by removing a layer of metal. Boring is done until the repair dimensions are obtained, after which new repair pistons and rings are installed there. As for the liner, it is used in situations where the walls have strong and deep damage, which does not allow to eliminate them by boring. Additionally, the liner method is used in situations where the cylinders were previously bored to their maximum repair dimensions. There are some motors where the factory does not provide boring because there is no possibility of installing pistons of repair size. That is why in this case, liners are used immediately. The concept of liner. To begin with, motorists should be familiarized with such an element as a cylinder liner. In essence, it is a removable insert, sleeve, which is installed in the cylinder block. So we can say that the task of the liner is to perform the functions of the block wall, since the piston will move inside it when the repair is completed. The volume of the liner used directly affects the displacement of the cylinders used. The process by which the liner is inserted into the cylinder is called lasing or block lasing. The installation process is quite complex. It is not possible to simply take the liner, insert it inside the block, and put it back together. Preliminary preparation is necessary. In the course of works, special equipment is used. The liners used in the overhaul are divided into two categories. These are wet and dry elements. Dry ones are not in contact with the cooling liquid. The wet type is arranged so that one of its sides is in contact with the coolant. They have additional seals, which do not allow antifreeze to penetrate into the cylinders. In parallel, they block the breakthrough of gases formed in the cylinders into the cooling system. When it comes to repairs, wet liners have the advantage. When choosing liners or sleeves, they should be subject to a number of basic requirements. They should be corrosion resistant, resistant to mechanical stresses, resistant to thermal stresses, made of high-strength materials. If they are sleeves with additional gaskets, then it is important to consider also the point of contact between the block and the sleeve. The shape and wall thickness of the product should not be forgotten. If necessary, specialists take into account the absence or availability of tolerance for additional boring of the sleeve itself after installation work. That is, the sleeve, liner, can be installed in the block and then bore to the required parameters corresponding to the dimensions of the piston. When and for what purpose Gilzofka appeared. Many people are rightly interested in why the engine liner was needed and when they first began to carry out such procedures. Initially, lasing was used to reduce the total weight of the power unit. In many ways, a huge step towards reducing the weight of the internal combustion engine was the introduction of aluminum, which gradually began to displace cast iron. Although cast iron is strong and cheap, it is still 3 times heavier than aluminum. Plus, it suffers from such a disease as corrosion and has lower thermal conductivity. In order to cool these blocks, much more cooling fluid was needed. The introduction of aluminum blocks was first attempted in the 1930s when they were installed on sports cars. Lightweight engines had aluminum blocks, in which wet type of cast iron liners were inserted. About 20 years later, aluminum was introduced into mass production of automobiles. At that time, cast iron had not completely left the market, because at that time it was difficult to carry out liners. The problem remained the reduced rigidity of the block, high loads on the used liners, rapid process of burnout of block gaskets even, when overheating was insignificant. Already in the early 70s, engineers switched to the active use of dry cast iron liners inside the aluminum block. Technically, it was difficult to press the heated cast iron liner into the softer aluminum. Plus, both metals have different coefficients of thermal expansion. This resulted in gaps between the liners and the block walls when the engine reached its operating temperature. Aluminum did not surpass cast iron in stiffness, but the overall weight of the block was reduced significantly. A little later, as technology progressed, engineers switched to a procedure in which the liners were not pressed in, but cast around the block. The cast iron liner resembled a small insert that was melted into the aluminum. As a result, the strength was increased, but further pressing out became impossible. That is, the motors lined with such technology became unrepairable. Thus, the period of disposable internal combustion engines actually began. Gradually, manufacturers completely abandoned cast iron liners, ceasing to use them in aluminum blocks. It is also relevant to learn about the resource of the engine that has undergone liner procedures. That is, motorists are interested in what service life can be the motor after a professional liner. In fact, the service life depends largely on a number of factors and the correctness of the entire procedure, starting with the preparation and selection of liners, ending with the back assembly. But it is possible to say how long a linered engine lasts on average. After such an overhaul, the operating life of the engine can be 100 to 150,000 kilometers. This is a solid period, given the difference in financial costs for overhaul and the purchase of a new, even if used, engine. Read also how you can remove errors from the car onboard computer in order for the internal combustion engine to be able to serve such a period. After the completion of all works and the beginning of operation, you should not forget about the elementary rules of maintenance. Further development and unrepairable blocks. The automakers did not stop there. The decision to eliminate the use of cast iron and liners proved to be the right one. This ensured a simplified and cheaper production process. They eliminated the need to press the sleeves, cast blocks around the so-called cups, etc. The use of solid aluminum blocks was also eliminated. At the same time, the one-piece aluminum block meant that there was no need to consider the temperature parameters of different materials, i.e., aluminum and cast iron. This allowed for better cooling. But the problem of aluminum softness remained unchanged. Since strong steel rings are used on the pistons, under active use they would quickly begin to destroy the aluminum cylinder itself. It became necessary to give the cylinder mirrors additional strength. To achieve this, the developers started to try different coatings based on ultra-high-strength materials. As a result, the world saw the first aluminum block engines. They were put into mass production in 1971. The basis was a sprite of aluminum, where 17% silicon was added. To describe briefly, the mirror of the working cylinder was subjected to sharp and strong cooling, which allowed the silicon to crystallize. Then the area was treated with various acids. They removed the remaining aluminum at the molecular level. As a result, a high-strength solid wall appeared inside the cylinder, on which pistons with steel rings ran quite freely and without risks of damage. The technology seemed very promising, which led to its further development. As a result, aluminum sleeves saturated with silicon appeared. Despite the apparent victory of aluminum over cast iron, in practice everything turned out to be not so rosy and promising. The problem of poor resistance to mechanical influences, which caused scoring, remained. After all, despite the high-strength layer, it was thin, and underneath it was soft aluminum metal. The next stage of development was a special technology that involved sealing the walls by electroplating with nickel and silicon carbide. This technology is well known to fans of Audi and BMW cars. The Bavarians went a little further, releasing a motor with aluminum-improved liners, while making all other components on the basis of magnesium alloy. This significantly reduced the weight of the internal combustion engine. Currently, engineers are actively working to make cylinder wall processing technology even more robust, durable, and efficient. As a result, laser alloying, plasma application, titanium, etc., have appeared. All the efforts of the developers were aimed at increasing the internal combustion engine resource and reducing its weight. In theory, everything looked rosy and promising. But in practice, a number of disadvantages of the so-called unrepairable cylinder blocks appeared. Aluminum BCs could quickly fail and could not be restored in case of certain breakdowns. At the same time, replacement of the entire block cost a considerable amount of money, amounting to about 20 to 30% of the value of the car, and in some places even more expensive. Aluminum blocks could not provide a solid motor resource, which averaged 300,000 kilometers for different car manufacturers. If to compare with cast iron blocks, or blocks made of aluminum, but cast iron, they overcame 400 to 500,000 kilometers without any problems. There are also legendary millions. Taking into account the existing disadvantages due to low resource and high cost of BC replacement, the question of repair of supposedly unrepairable blocks became acute. And here liners became the salvation. Specialists have been practicing lasing of aluminum BCs for many years, despite the fact that officially they are not subject to restoration. This procedure was not the cheapest and simplest, but compared to the purchase of a new block or a complete engine, it still reduces the costs of the car owner. If everything is done competently and in accordance with the technology, the resource of the internal combustion engine after lasing will be no less than that of a contract engine or an old internal combustion engine with a new block. Therefore, the cost of lasing is often fully justified. At the moment, almost any motor can be lined. The main thing here is the presence of sufficient wall thickness, which will allow the restoration with liners. If there are problems with the engine, it is possible to find the right-sized liners for the engine and mount them inside the block. Liner procedure. According to experts, the lasing of an automobile engine cylinder block is possible for any internal combustion engine. That is, various motors are subject to such repair. Masters usually know which engines are originally lined at the stage of car production, i.e., lined from the factory, and which engines are positioned as unrepairable. Since we have realized that all types of internal combustion engines are reparable, the presence or absence of liners from the factory does not play a decisive role. If the block was lined at the factory, then most often we are talking about wet liners. The repair is to replace the worn bushing with a new one. This is the simplest variant of liner among all existing ones. In some cases, the work is carried out manually. To do this, it is enough to pick up the necessary and suitable repair sleeves. It is also erroneous to believe that absolutely all bushings are subject to replacement during lasing. This depends directly on which ones are worn out. Only those that have already used up their life can be replaced. The rest remain in their places and are operated until, and on them, do not form scoring and damage. Read also, gearshift paddles, what it is and how to use them if you are facing a non-horizontalized block, that is, the motor from the factory does not provide for the use of liners in its design, and it should be picked up dry liners. Such a task becomes noticeably more difficult. Cast iron blocks are fitted with bushings made of alloyed cast iron. If the block is made of aluminum alloy, then aluminum bushings should be used. It should be remembered that alloys for BC can have various additives and additional components. Special reinforcing materials are also applied to the walls themselves, which provides improved resistance to damage and scoring. Therefore, it is better if a qualified specialist is responsible for the selection of the liners. Sleeving can be divided into press fit and hot sleeving. Pressing is used in situations where it is necessary to replace old liners with new sleeves. Here it is necessary to pre-bore the cylinders in order to create a perfectly even and correct geometry for seating the new liners. Not even the slightest deviation is allowed during boring. Otherwise, the pistons and their rings will not function properly. After boring, the bushings are pressed in, the appropriate pistons are installed, and the engine is reassembled. In the case of hot boring, when a dry bushing is mounted, the process looks like this. BC is heated to about 150 degrees Celsius. The selected bushing is cooled using liquid nitrogen before installation. A solution is applied to the sleeve to prevent condensation from forming when the cold sleeve is inserted into the hot block. The sleeve is inserted into its prepared place. This method of rebuilding the BC is optimal in terms of quality, as the technology makes it possible to create a tight fit and ensure tension in the areas where the sleeve and block come into contact. The bushing itself easily slides into place, literally under its own weight. A little tapping with a hammer is all that is required to get it fully seated. In the case of hot sleeving, no extra force is needed for pressing, unlike the first considered method of replacing the old bushing with a new one. But there are some exceptions. When the aluminum BC is not pre-bored, then the installation of the bushing is carried out by pressing. The procedure differs by the fact that before installation, the socket for the sleeve is lubricated with sealant. Then the new element is pressed in. In practice, everything looks much more complicated. That is why lasing should be entrusted only to highly qualified specialists with extensive experience, knowledge, and relevant skills. It is not recommended to try to liner BC with your own hands. Without special tools and equipment, it is practically impossible to do it qualitatively. If you follow the rules, follow all the recommendations, and strictly take into account all the technological features of lasing minimally, the life of the internal combustion engine will be extended by 100,000 kilometers. But in some cases, cars easily overcome the mark of 150 to 200,000 kilometers while correctly maintaining and operating the motor. Some subtleties of lasing. To somehow summarize the results, make some clarifications and additions, we can sort everything out, tell some nuances and important points. BCs are aluminum and cast iron, and are also divided into one-piece and factory liners. There are blocks made of aluminum, but not designed to use repair pistons. If it is a one-piece BC on the basis of cast iron, its walls are necessarily covered with extremely rare are motors in which steel liners are additionally used inside the cast iron block. Most aluminum block engines have liners. It is extremely rare to find solid cast versions. Many modern power units are equipped with aluminum BCs, supplemented with dry liners. Here, special hard coatings are applied to the block walls, with which the piston comes into contact during engine operation. Depending on which coating is applied, it is possible to apply repair pistons in the BC and to carry out lasing. Aluminum bushings are commercially available for this purpose. There are also such aluminum blocks, where the installation of enlarged pistons with rings is considered impossible, since the manufacturer does not produce repair kits. But even such blocks can be lined. Problems with lasing cast iron blocks are much less than with installation of bushings in aluminum BCs. This is due to the high cost of factory bushings, because for one liner can require about $150. In such a situation, only the repair of one cylinder is financially justified. The use of cast iron bushings for aluminum BCs is considered an alternative. This method of repair is actively used in CS countries. When one cylinder is lined, the geometry of the neighboring cylinder is disturbed. With properly conducted work, cast iron bushing in the aluminum block is able to extend the life of the internal combustion engine for 150,000 kilometers. In this day and age, getting a quality gyroplated engine is not that difficult. There are a large number of craftsmen and car services offering such services. In fact, lasing can be considered one of the most effective methods against a kind of conspiracy of car manufacturers. They refuse to produce durable internal combustion engines because they realize the advantages of producing less resistant to wear motors. This way, consumers are more likely to buy new cars. In order to somehow extend the life of your engine, the method of lasing is actively used in the case of BC wear. This is a real way to increase the life of the engine, as well as a few more years to operate your car. In conclusion, understanding what an engine liner is and the process of installing one is crucial for maintaining engine performance and longevity. Engine liners provide a protective barrier, enhancing durability and efficiency while minimizing wear and tear. Whether you're a seasoned mechanic or a car enthusiast, knowing how engine liners are fitted can help you appreciate the intricacies of engine design and maintenance. Thank you for watching, and we hope this video has shed light on the importance of engine liners in automotive engineering.